Physics paper, question 1. The time dependence of a physical quantity P is given by P equals to P0 e raised to alpha t square minus alpha t square, where alpha is a constant and t is time. Then constant alpha is, now here alpha t square is a dimensionless quantity. Therefore, alpha would be basically 1 by t square when I want to take the dimensions of it basically. So the dimensions of this would come out to be t raised to minus 2. So the correct answer here would be dimensionless of t raised to minus 2. That is option B would be our correct answer. Question 2. In the equation Sn, the Snth equals to u plus a by 2 2n minus 1. The letters have their usual meanings. The dimensional formula of Sn is, so S is nothing but sum. That is, S represents in this case the distance covered in the nth second. So since S represents the distance covered in the nth second, so the dimensions of that will be the dimensions of distance. That is m0 L t0. That is option D would be your correct answer. Question 3. A packet is dropped from a balloon which is going upwards with a velocity 12 meters per second. The velocity of the packet after 2 seconds will be, when the packet is released from the balloon, it acquires the velocity of the balloon, that is 12 meters per second. Hence the velocity of the packet after 2 seconds will be given by v equals u plus gt, where your initial velocity is 12, g is 9.8 and t is 2. So that will be minus 76 meters per second. So your correct answer, minus 7.6 meters per second. So your correct answer here is option C. Question 4. A body of mass m is projected at an angle of 45 degrees with the horizontal. If air resistance is negligible, then total change in momentum when it strikes the ground is. Change in momentum would be given by 2 mv sine theta. Theta value is 45, so substitute, you will get root 2 mv as your answer. So option B is your correct answer. Question 5. In uniform circular motion, the velocity vector and acceleration vector are. Velocity is always tangential and centripetal acceleration is radial. So basically they are perpendicular to each other. That is option A. Question 6. A heavy uniform chain lies on horizontal tabletop. If the coefficient of friction between the chain and the table surface is 0.25, then the maximum fraction of length of the chain that can hang over one edge of the table is. So basically this is how the table is, this is how the chain is. So we have to find how much part of the chain will hang down the table. So that let that length be x. If the total length of the chain is L, then this much length will be L minus x. So here in this case, pulling force F would be equal to mxg by L, and friction force small f would be equal to mu n. Your capital N here is mu m by L, L minus x, g. That is basically, this is your, this part of the chain, there is frictional force acting, and this part of the chain there is a pulling force acting. Now for equilibrium, your frictional force would have to be equal to your pulling force. So I would obtain mgx by L equal to mu m L minus x g divided by L. So your L, your g gets cancelled out, your m gets cancelled out. So you get x equals to L by 5, which basically means 20%. So 20% is what would the answer would be. Question 7. A force of 1200 Newton acts on a 0.5 kg steel ball as a result of collision lasting 25 milliseconds. If the force is in a direction opposite to the initial velocity of 14 meters per second, then the final speed of steel ball would be. Now initial velocity is given as 14 meters per second, mass of the ball is 0.5 kg, force acting on the steel ball from opposite direction would be minus 1200 Newton. Time duration for collision is 25 milliseconds, which will be 25 into 10 raised to minus 3 seconds. Let the final velocity of the ball be v. Now, using Newton's second law of motion, this is how the ball is moving with u equals to 14 meters per second. This is how the force is 1200 Newton. This will be the velocity v that is we are supposed to find. Final speed of the ball, that is v. Now force F is P2 minus P1 divided by T. So that means minus 1200 equals mv minus mu divided by T. Now from here v would be equal to minus 1200 divided by m plus u. Substituting all your values, you will get v value as minus 60 meters per second. So the resultant v would be minus 60 plus the 14 meters per second, that is when it is moving this direction. So you will get the answer as minus 46 meters per second. So correct answer here is option D. Question 8. A spring which is initially in its unstretched condition is first stretched by a length x and then again by a further length x. The work done in the first case is W1 and the second case is W2. The work done in stretching a spring by initial length x would be, that is W1 would be k half k x square. Work done in further pulling the string, that is W2 would be half k 2x square minus half k x square. So your W2 would be half k 4x square minus half k x square, that is half k 3x square. So W2 is equal to 3 times half k x square, that is basically 3 times W1. So your correct answer is option C. Question 9. Which relation is not correct of the following? Torque equals moment of inertia into angular acceleration. Not correct. Which is torque is moment of inertia into angular acceleration. This is correct. Torque equals dipole moment into magnetic induction. This is also correct. Moment of inertia is torque divided by angular acceleration. This is also correct. Option D, linear momentum equals moment of inertia into angular velocity. This is not correct. So here your answer will be option D. Question 10. A ball falls freely from a height of 45 meters. When the ball is at a height of 25 meters, it explodes into two equal pieces. One of them moves horizontally with a speed of 10 meters per second. The distance between the two pieces when both strike the ground is. Now let at the time of explosion the velocity of one piece of mass is 10 I. That is 10 meters per second, that is given. It will be 10 I. That one piece of mass will be m by 2. If the velocity of the other be v2, then from law of conservation of momentum, horizontal component of v2 must be minus 10I. Therefore, relative velocity of two parts in horizontal direction is 20 meters per second, because that one is to 10I, the first mass is 10I, the second mass is minus 10I, so relative velocity of the two parts in horizontal direction will be 20 meters per second. Time taken by ball to fall through 45 meters would be 20 equals to root of 2h by g, which is root of 2 multiplied by 45 by 10, which is 3 seconds. And time taken by ball to fall through first 20 meters, that is t dash, be 2 h dash divided by g, should be equal to 2 into 20 divided by 10, which is 2 seconds. Hence, time taken by ball pieces to fall from 25-meter height to the ground would basically mean 3 seconds minus 2 seconds. That is 1 second is what it will take after they explode to reach the ground. Horizontal distance between the two pieces at the time of striking the ground would basically mean velocity into the time, which is 20 meters. The correct answer is option B. Question 11. If the density of Earth is double keeping radius constant, then the new acceleration due to gravity is, now g is equal to 4 by 3 pi multiplied by density multiplied by capital G and r. So acceleration due to gravity is directly proportional to density. So g1 by g2 will be equal to density 1 by density 2. So since we already know the relations, we can substitute. We get g2 would be equal to 19.6 meters per second square. Question 12. The general form of potential energy curve for atoms or molecules can be represented by the following equation. U bracket r equals to a by r raised to n minus b by r raised to m. Here r is the interatomic or molecular distance, a and b are coefficients, n and m are the exponents. In the above equation, option A says first term represents the attractive part of the potential. Option B says second term represents the attractive part. Option C says both represent the attractive part. Option D says second term represents the repulsive part. So in this equation, the second term will represent the attractive part of the potential. So hence your option B would be your correct answer. Question 13. Water flows steadily through a horizontal pipe of variable cross section. If the pressure of water is P at a point where flow speed is V, and the pressure at another point where the flow speed is 2V is, so when pressure is P, velocity is V, we have to find what will be the pressure when velocity is 2V. From Bernoulli's equation, the sum of all forms of energy in a fluid flowing through an enclosed path is the same at any 2 points in the path. Therefore, I can say that pressure initial plus half rho V1 square equals to P dash plus half rho V2 square. Now it is given that V2 equals to 2 times V1. So I will have pressure plus half rho V1 square equals to P dash plus half rho V2 times V1 the whole square. Solving this will give you P dash equals to P minus 3 by 2 rho V1 square. That V1 can be taken as V. So your correct answer here would be option A. Question 14. Two capillaries of radii R1 and R2, length L1 and L2 respectively, are in series. A liquid of viscosity eta is flowing through the combination under a pressure difference P. What is the rate of flow of liquid? The rate of flow of the liquid through the capillary is given by V equals pi pressure R raised to 4 divided by 8 eta L, which equals to pressure pi R raised to 4 divided by 8 eta L, can be written as pressure divided by capital R, where capital R is nothing but a resistance. So the entire bracket basically here is 1 by R. So where your R represents 8 eta L divided by pi r raised to 4. When two tubes are in series, total resistance R is R1 plus R2. Rate of flow of liquid rho dash should be equal to pressure divided by R1 plus R2. Pressure divided by 8 eta by pi L1 divided by R1 raised to 4 plus L2 divided by R2 raised to 4. So this, on simplifying, will basically give you the correct answer as option D. Question 15. If the ratio of densities of two substances is 5:6 and that of specific heat is 3:5, then the ratio between heat capacities per unit volume is. Heat capacity per unit volume is given by C multiplied by M divided by V. That is basically C multiplied by density. Desired ratio that we are supposed to find, that is ratio between heat capacities per unit volume, is C1 rho 1 divided by C2 rho 2. Now C1 C2 relation is given, rho 1 rho 2 relation is given, substitute, will get the answer as 1 by 2, that is 1:2, that is option C is the correct answer. Question 16. A diatomic ideal gas is compressed adiabatically to 1 by 32 of its initial volume. In the initial temperature of the gas is Tf and the final temperature is Tf, the value of A is, the value of A, the correct answer would be 4. Question 17. The value of adiabatic bulk modulus of elasticity of helium at NTP is K alpha equals gamma P, which is 5 by 3 multiplied by 1.01 multiplied by 10 raised to 5. Answer is 1.69 multiplied by 10 raised to 5. That is option C is the correct answer. Question 18. Which of the following cylindrical rods will conduct maximum heat when their ends are maintained at a constant temperature difference? Delta Q by delta T is equal to Ka delta capital T divided by delta X, which is equal to K pi r square delta capital T divided by small l, which can be said as proportional to, that is delta Q by delta T is proportional to r squared by L. So as r square by L is maximum, so when r square by L is maximum, that is when we would have delta Q by delta T maximum. So when will r square by L be maximum? For the option D is when r square by L will be maximum. Question 19. In simple harmonic motion, the ratio of acceleration to the particle to its displacement at any time is a measure of angular frequency. So option C. Question 20. Acceleration A and time period capital T of a body in SHM is given by a curve shown below. Then corresponding graph between kinetic energy and time T is correctly represented by. So this is the graph that is between acceleration and time. So we have to identify which is the correct graph for kinetic energy versus time. Now in SHM, when acceleration is negative maximum or positive maximum, that is when acceleration is either negative maximum or positive maximum, the kinetic energy is 0. Similarly, for zero acceleration, velocity is maximum and kinetic energy is also maximum. So when acceleration is 0, that is at these 2 points, kinetic energy would be maximum. And when acceleration is maximum, kinetic energy should be 0. So here your correct answer, option that represents, correct graph that represents your answer is option A. Question 21. A string is rigidly tied at two ends and its equation of vibration is given by y equals cos 2 pi t sin 2 pi x. The minimum length of the string is. Now the given equation y equals sine 2 pi x cos 2 pi t are compared with the standard equation, which is y equals to 2a sine 2 pi x by lambda cos 2 pi x by 2 pi t by n, cos 2 pi t basically. So y equals 2a sine 2 pi x by lambda cos 2 pi n. So on comparing, or cos 2 pi t basically, so on comparing, I will get that 2 pi x by lambda is here in this equation is 2 pi x. So your value of lambda is 1. Minimum distance of string, that is length, minimum will be lambda by 2, which is half meter. So option B is your correct answer. Question 22. 2-point charges repel each other with a force of 100 Newton. One charge is increased by 10%, other is reduced by 10%. The new force of repulsion at the same distance would be. Force is proportional to Q1, Q2. So initial charges were 100, both. One is increased by 10%, so one will become 110. Other is decreased by 10%, so other will become 90. So your new force will be 110 divided by 100 multiplied by 90 divided by 100, which will basically give you 99 by 100 times. So the new force will basically be 99 newtons. That is option C. Question 23. Two equal charges as separated by distance d. A third charge placed on a perpendicular bisector at x from center will experience maximum Coulomb force when. Now force is given by again same equation, 1 upon 4 pi epsilon 0 q1 q2 by r square. Now here net force will be 2f cos theta, which will be given by 2 multiplied by 1 by 4 pi epsilon 0 q small q x divided by x square plus d square divided by 4 the whole raised to 3 by 2. Now for maximum force, this derivative of this net force should be equal to 0. So on differentiating this, we would obtain 2x square equals to d square by 4. So your x value will be d by 2 root 2. So the correct answer here is option C. Question 24. The electrostatic potential energy between proton and electron separated by a distance 1 angstrom is. U is equals to, again same thing, force 1 upon 4 pi epsilon 0 q1 q2 by r, that is potential in this case. U is equals to, substitute all the values, you have 9 into 10 raised to 9 multiplied by charge of electron minus 1.6 10 raised to minus 19 divided by 10 raised to minus 10. You will get the answer as 14.4 eV with a negative sign. So option C would be your correct answer. Question 25. A tap supplies water at 22 degrees Celsius. A man takes off 1 liter of water per minute at 37 degrees Celsius from the geyser. The power of geyser is. Now mass of water, volume into density. Volume is 1000 ml. That is 1 liter given, density would be 1, so mass of water will be 1000 gram. Heat taken by water will be mc delta theta. So m is 1000 gram, c is 1, delta theta will be 37 minus 22. We will get here, we will convert this to calories, that is joules, that is multiplied by 4.2. So we will get the value of heat. Power would be heat energy divided by the time. The time here is given as 60 seconds basically per minute, that is 60 seconds. So heat divided by 60 seconds, the answer should be 1050 watts, that is option B. Question 26. A thermocouple develops 200 microvolt between 0 degree Celsius and 100 degree Celsius. If it develops 64 microvolt and 76 microvolt respectively between 0 to 32 and 32 to 70, then what will be the thermo EMF it develops between 70 and 100? Now, by using a very simple principle, that is thermo EMF developed between 0 to 100 would be equal to that developed between 0 to 32, then 32 to 70, then 70 to 100, that is addition. So basically 200 would be equal to 64 plus 76 plus the thermo EMF between 70 to 100. So thermo EMF between 70 to 100 would be 200 minus 64 minus 76. So correct answer here would be 60 microvolt. Question 27. What will happen when 40 volt 220 volt lamp and 100 watt 220 volt lamp are connected in series across 40 volt supply? Now, the bulb ratings are given. Current rating for the first bulb would be 40 by 220, that is 2 by 11 amperes. Resistance would be V square by P, that is 220 square divided by power, that is 40, that is 1210 ohm. For bulb 2, we'll get I2 as 5 by 11 amperes and same way R as 484 ohm. When both are connected in series across a 40 volt, both are connected in series, so total current would be 40 divided by P1 plus P2, that is R1 plus R2. So that will be adding both the resistances since they are in series. 40 divided by 1254, which is 0.03 amperes. This current is less than the rated current of each bulb. Hence, neither bulb will fuse. Another way of answering this question and a shorter way is, if the voltage applied is less than the voltage rating of the bulb will never fuse. That is, this voltage that is applied, 40 volt, is less than these voltages. That is why the bulb will never fuse. So now option D would be a correct answer. Neither lamp will fuse. Question 28. 4 charged particles are projected perpendicularly in the magnetic field with equal, which will have minimum frequency. Now frequency is given by BQ divided by 2 pi small m. Proton, electron, lithium, helium have same charge in magnitude, that is lithium plus ion and helium plus ion have same charge in magnitude, and since magnetic field is also constant, F would be inversely proportional to small m. Now among the given charged particles, lithium Li has highest mass, that is Li plus, therefore it will have the minimum frequency. So here option C would be your correct answer. Question 29. A bar magnet of magnetic moment 10⁴ joules per Tesla is free to rotate in a horizontal plane. The work done rotating the magnet slowly from a direction parallel to a horizontal magnetic field of 4 multiplied by 10⁻⁵ Tesla to a direction 60 degree from the field will be. Magnetic moment of the bar, capital M, is 10⁴ joule per Tesla. Magnetic field is given by 4 multiplied by 10⁻⁵ Tesla. Work done will be MB. Multiply both of them, that is basically MB cos theta. So substitute all the values, you will get the answer as 0.2 joules. That is option A. Question 30. A bar magnet is oscillating in the Earth's magnetic field with time period T. If its mass is increased 4 times, then its time period will be. Time period is given by the equation 2 pi root of I by M B H suffix H. where I is the moment of inertia, capital M is the magnetic moment, and BH is the horizontal component of Earth's magnetic field. So I equals mr square in this case, because it's a bar magnet, where small m is the mass, r is the radius. When mass is increased 4 times, I dash will be 4 times the original I. So T dash will be 2 pi root of 4 times I divided by MBH. Now root of 4 will be 2, so this will basically give you T dash will be equal to 2 times the original time period. The correct answer is option B. Question 31. The current I in an induction coil varies with time t according to the given graph. Which of the following graphs shows the induced EMF E in the coil with time t? Now, there are 3 parts, part A, part B, part C to this graph. Now, EMF induced during part A would be 0 because your current remains constant irrespective of the time. EMF induced during part B is constant, and EMF induced during part C is constant again. So during part B, that is EMF induced during part B and EMF induced during part C, they are nothing but same values but in opposite directions. So they will cancel out each other. So here the correct graph that represents the EMF is, initially the EMF would be 0. Then when there is a downward slope to the current, the EMF would increase, will have a fixed constant value, and then it will, when the slope is again upwards, the EMF will have this fixed constant value, but both in opposite direction. So option C is your correct answer. Question 32. The natural frequency omega 0 of oscillations in LC circuit is given by F is equals to 1 upon 2 pi root of LC. So correct answer is option A. So F is 1 upon 2 pi root of LC. If you got talk about omega, it will be 1 upon root of LC. So if they ask you frequency, it is this. If they have asked you angular frequency or angular velocity, it will be 1 upon root of LC. Question 33. A resistor and a capacitor are connected in series with an AC source. If the potential drop across the capacitor is 5 volt and that across the resistor is 12 volt, then the applied voltage is, now voltage across the resistor 12 volt, voltage across the capacitor 5 volt. Resultant voltage VR square plus VC square, which will be 13 volt. The correct answer is option A. Question 34. The wave of wavelength 5900 Armstrong emitted by an atom or molecule must have some finite total length which is known as the coherence length. For sodium light, this length is 2.4 centimeter. The number of oscillations in this length will be, now number of oscillation in coherence length will be L by lambda, which is 0.024 divided by 5900 multiplied by 10 raised to minus 10. Solving this will give you 4.068 multiplied by 10 raised to 6. That is, your correct answer is option C. Question 35. A large glass slab having refractive index 5 by 3 of thickness 8 centimeter is placed over a point source of light on a plane surface. It is seen that light emerges out of the top surface of the slab from a circular area of radius r centimeter. What is the value of r? Now, this r is nothing but T tan theta c, that is basically theta c is the critical angle. Now we know sin theta c is 1 upon mu, which would be 3 by 5. Tan theta c we would obtain from sin theta c as 3 by 4. So your r value, thickness is given by 8 centimeters. So your r value will be 3 by 4 multiplied by 8, which is 6 centimeter. So correct answer is 6. Question 36. A light ray is incident upon a prism in minimum deviation position and suffers a deviation of 34 degrees. If the shaded half of the prism is knocked off, the ray will. Now here, by the formula of deviation is equal to mu minus 1 into the angle of prism. Here the deviation is given as 34. So I'll get mu minus 1 into A equals to 34. Now in the second position, angle of deviation delta dash would be mu minus 1 A by 2, because we'll be knocking off the shaded portion, because of which the angle of the prism would become half. So dividing both, we would get 34 divided by delta dash equals to mu minus 1 A divided by mu minus 1 A by 2. So we will get delta dash would be equal to 17 degree. So suffer a deviation of 17 degrees, what the answer would be. Question 37. If the fringe width when lambda is equals to 5.89 multiplied by 10 raised to minus 5 centimeter is 0.431 mm, and shift of white central fringe on introducing a mica sheet in one path is 1.89 mm, thickness of the sheet will be. Now x0 is given by capital D by small d mu minus 1 into thickness. Fringe width is given by capital D lambda divided by small d. So W fringe width divided by lambda will be equal to capital D by small d. So this formula will change as x0 equals to width divided by lambda mu minus 1 into the thickness. Now x0 is given as, that is after introducing the sheet, the shift is 1.89 mm, that is 10 raised to minus 3, equals to W, that is given as fringe width 0.431 multiplied by 10 raised to minus 3 divided by wavelength 5.89 multiplied by 10 raised to minus 7 in terms of meters, and mu is given by 1.59 minus 1 into the thickness. From here, on calculating, we would obtain the thickness as 4.38 multiplied by 10 raised to minus 6 meters. So 438 is what the answer. So option A would be your correct answer. Question 38. In vacuum, an electron of energy 30 keV hits tungsten target, then emitted radiation will be X-rays. Question 39. Cathode rays are similar to visible light rays as. Option A, they both can be deflected by electric and magnetic fields. They both have a definite magnitude of wavelength. Option C, they both can ionize a gas through which they pass. And option D, they both can expose a photographic plate. Actually, correct answer is option D. They both can expose a photographic plate. Question 40. The ionization energy of lithium Li2 plus is equals to. Ionization energy is given by RCH square. Z for Li2 plus is equal to 3. Substitute. So we get 3 square RCH, which is 9 RCH. So correct answer is option A. Question 41. The diagram shows energy levels of an electron in a certain atom, which transition shown represents the emission of a photon with the most energy. So here transition 1 is from n equals 1 to n equals 3. Transition 2 is from n equals 4 to n equals 3. Transition 3 is from n equals 2 to n equals 1, and transition 4 is from n equals 4 to n equals 2. Now emitted energy is given by hc by lambda 1 by ni square minus 1 by n1 square minus 1 by n2 square. Final initial. So on substituting your n values for all four conditions, you will obtain for which of the combinations the energy is maximum. So here, after solving, you will obtain that when the transitions from n equals 2 to n equals 1, the energy is maximum. So option C would be your correct answer. Question 42. Consider two nuclei of the same radioactive nuclei. One of the nuclei was created in a supernova explosion 5 billion years ago. The probability of decay during the next time is different for each nuclei. Nuclei created in explosion decays first. Option C, nuclei created in the reactor decays first. Option D, independent of the time of creation. So the correct answer is radioactive decay does not depend upon the time of creation. So option D would be your right answer. Question 43. The main cause of Zener breakdown is. Now Zener breakdown is because of production of electron hole pair due to thermal excitation. So here the correct answer will be production of electron hole pair due to thermal excitation. That is option B. Question 44. For a good demodulation of AM signal of carrier frequency f, the value of RC should be 1 by f should be less than RC, or RC, basically this can also be done, RC should be greater than 1 by f. So that basically the correct option here is option D. Question 45. A given fiber has a core refractive index of 1.5 and a core cladding index difference factor of 0.01125. The numerical aperture is equals to mu1 to delta raised to half. Mu1 is 1.5, that is core refractive index. Delta value is 0.01125. Substitute, that is 2 multiplied by 0.01125 raised to half. Get the answer as 0.225. That is option B would be your right answer.